Question 30 is looking at a council stockpile. They have 40% disappears every year due to erosion and composting. They've got 30 tonnes of pine bark delivered, and they top it up by delivering 8 tonnes per year. So we need to write that as a recurrence or difference equation. Now, 40% disappears, so that's 1 minus 0.4 or 0.6 times Tn, and they top it up by 8. Initially, they have 30 tonnes, so T0 is 30 tonnes. So if we generate the first 5 terms of that, easy to do that on the calculator, this is what we'll have. 30 drops to 26, 23.6, 22.16, 21.3. Now, if we plot that for longer, it says to 25, I've got it to 20, but I can easily make that to 25. What we'll look at there is a case of a steady state being reached. Just generate that again. And you can see there we seem to be attaining a steady state of 20.0 tonnes. Let's just have a look at that graphically, and I'll just do the analysis trace. So you can see flattening along at 20. I'll just write that down. So C, you can sketch that if you wish. D, we have a steady state of 20.0 tonnes at about or after 20 years. Now, if we want to attain a steady state at the initial figure, that means that T the n plus 1, what it is at the end of the year, has to equal what it is at the beginning of the year or the previous year's end, and that's equal to 30 tonnes. Now, we've got to assume that the composting and the erosion, etc., still occurs, but D is what we need to find. So I'm going to solve for D. So 30 is 0.6 times 30 plus D, and D is equal to 12 tonnes per year. So I need to deliver that per year. I'll just quickly generate that as a second instance on my calculator and hopefully be able to see what's happening. Now that's Bn. Now we have to deliver 12 tonnes a year, starting at 30. Generate the table. You can see that constant 30. And as a graph, you can see the flat line at 30 tonnes per year is maintained.